Here we have another circuit. It's a little more complicated than the circuit that we had in problem 1, but still not that bad. And we have, we're given some information. We're given that V1 is 12 volts. That means that the change in voltage across that resistor is 12 volts. If I wanted to assign a voltage, a ground voltage, at the bottom here, make that 0 volts, then I would say the voltage right here would be 12 volts. So I could do that if I wanted to. So my first part on part A is to find the current I1. Well, I1 is the current through this resistor, and I have its resistance, it's 6 kilo ohms, and I have the voltage across it. So that means I can just use Ohm's law, so V equals IR. And that voltage is going from the positive side to the negative side, and that's the same direction the current is going. So my signs are all correct. So that's 12 equals I1 times R is 6 kilo ohms. And it's helpful to remember that 1 over a kilo is a milli. And because a lot of times you'll see in the same problem, you'll have kilo ohm resistors and milliamp currents. And that's because a kilo times a milli is 1. And so you could change this if you wanted to. You could change this to 12 equals I1 times 6,000 ohms. But if you leave ohms in kilo ohms, then amps will be in milliamps. You do have to change them out of kilo when you're starting to deal with power, though, because then you would actually just need to use the 6,000 ohms. But so if I divide both sides by 6 kilo ohms, I get 2, and that'll be milliamps. So I1 is 2 milliamps. Alright, so let's see. Now I'm supposed to get the current, so I have 2 milliamps here. That's part A. Now I'm supposed to get I2. So there's different ways I could go about doing this. Let's see. I know that if I follow this path right here, I have a drop of 12 volts because there's 12 volts up here and 0 volts down here. And my equivalent resistance for that red branch that I just drew is 12 kilo ohms because those are in series. And so I can say that V equals IR, and my change in voltage is 12 volts. 12 equals I times my resistance is 12 kilo ohms. So 12 divided by 12 is 1, and so that will be 1 milliamp is I2. So I2 is 1 milliamp. Okay, so what that means, one thing that I'm just going to go ahead and fill in because I know it now, is if I2 is 1 milliamp, then by KCL, I know the current in this branch has to be 3 milliamps because coming into this node, I have to have the same current coming in as going out. So I know that. And then that will help me with part C, the voltage V2. So since I have 3 milliamps going across this resistor right here, I can say that V2 equals 3 milliamps times 2 kiloohms, or that V2 equals 6 volts. Now notice that means it's a 6 volt change across that resistor. And if it's a 6 volt change across that resistor, the current is going to the right, and so it went down 6 volts as it went across that resistor. Well, now if we're looking at voltages relative to our reference node, so our reference node was 0, and we lost 6 volts going across that resistor, and on the other side of the resistor, relative to ground, it's 12 volts, then it must be 18 volts on that side. So relative to ground, it has to be 18 volts higher on this side, because I have to have a drop of 6 from one side to the other. So having that information answers for me part D, which says what is my voltage source. And so my voltage source is going to be the change in voltage across the voltage source. If the bottom node is ground and the top is 18 volts, then my voltage source is 18 volts. Now, once you've done a problem like this, it can be useful to go through and find other things and make sure that it all adds up. So we're done with this problem, but to show you what I'm talking about, let's just do something else and make sure that our numbers, all make sense. So let's look at a KVL around the right-hand loop. If everything we did was correct, then the voltage changes going around that loop ought to be 0. Now now notice the direction I drew this. I'm going up through this middle resistor. I1 is going down. And so if I'm doing KVL on that loop, then I would take minus I1, which was 2 milliamps, times 6 kiloohms. So that would be my voltage drop across this. And I did minus because I'm going in the opposite direction of the current. And then plus, because I'm going in the direction of I2 was 1 milliamp, so 1 milliamp times 8 kiloohms takes care of this resistor. And then plus, I still have I2 going through this branch, 1 milliamp times 4 kiloohms on that one. And that equals negative 12 plus 8 plus 4, which is in fact 0. So KVL on that right-hand loop does work out. So that's just kind of a check to see, okay, well that makes me feel comfortable about it, that I did the right thing. Okay, any questions on this one? Alright, let me save it.